For this problem, if a MOSFET with W micrometers and L micrometers is biased in triode, I underlined this because it's an important part, what is the gate to drain capacitance CGD in femtofarads? We can assume the gate dielectric is silicon dioxide with a TOX 87.9 angstroms. And an angstrom is in the notes linked below the like button. Just added this section, and actually one of my classmates caught this. I made a mistake when I did this problem originally, and so we're going to be using this where he circled right here. It's important. We'll come back to this in a second, so we'll just come back here where there's a little bit less clutter. So let's write this out. We know we're in triode, so we're going to be using this equation right here. We have our CGS, and it's equal to our CGD. And we want to find our CGD, right? So we're going to set it equal to 1/2 of our C gate. And well, our C gate is the COX times our WL. And we can expand this, right? Our COX, we can say that it's going to be this EOX over TOX. And we can further expand this EOX. So we'll take this and we'll come down here, and we're going to say it's 3.9 times our 8.854 times 10 to the negative 14 farads per centimeter. Now there's a problem here. This is farads per centimeter, and we have these micrometers that we're going to convert into meters. So we're going to have to convert this. Well, we can't really convert how this is on the bottom. We could do like 1 centimeter over 10 to the negative 2, but then we're going to have this T to the X, TOX on the bottom, and this angstrom right here is, well, we can look at this actually. This is provided by one of the classmates. We have 1A is equal to 10 to the negative 10 meters, but it's also equal to 10 to the negative 8 centimeters. So instead of canceling out our centimeters, let's just use this. So that's going to go in there, and then we are just going to have to come back for this TOX to plug in 10 to the negative 8 centimeters. So going here, we have our formula, or our equation, as CGD is equal to, we're going to have our 1/2, and let's actually put all of our constants together. We'll have our W times L over 2. And then we are going to have our E and 3.9, so we'll just have the 3.9 times our 8.854 times 10 to the negative 14. And this is all going to be divided by our TOX. Now remember, this is in farads per centimeter, so it's going to be the kind of the same for what we have, the 10 to the negative 8 centimeters. Our TOX is 87.9, and just to keep it general, if you have any different numbers, we're going to do TOX times 10 to the negative 8 centimeters. This way, our centimeters are going to actually cancel out. And we're going to be, well, we can even cancel these out, but we won't worry about that right now. So we're going to close this off like this, and this is going to be our equation. So now we would just plug our values in. So if I go into Symbol Lab, we have our 3.9 times the 8.854 times 10 to the negative 4, and then our TOX here is 87.9 times 10 to the negative 8. We have our 10 times negative 6 twice for the 2 micros, and then we have our 1.8 and the 35 for the W and the L, and then we have our times 0.5 for this 2 here. So if we're to click go, it's going to calculate for us, and we're going to get approximately 1.237. So the answer here is 1.237 times 10 to the negative 17. Now there's a problem here. We want this in femtofarads, as it says right here. So instead of having it as 10 to the negative 17, we want it as 10 to the negative 15. So to get rid of 2 negatives, we're going to go over to the right twice. So we're going to have 123.7 times 10 to the negative 15, which is equal to a femto. So the answer here is going to be 123.7. Remember to look at units. That tripped me up first with the centimeters here, and when we actually convert it right here. So that's how we would go about solving this problem.